Okay, so enough with segments. Let's move on to angles, right? Okay, so just like the ruler postulate, we have a protractor postulate. Now, a protractor is the object we use to measure angles with. So instead of it being linear, it has this angular curve to it, right? So when you measure an angle using a protractor, right? So you have two sides of your angle. They are assigned almost like coordinates, but just numbers on the protractor, right? So in this case, if I'm looking at the measure of angle ABC, right? So we know that BA is at 0, and then BC comes up here to 60. All right. So to find the measure of angle ABC, you're just going to simply subtract 60 minus 0, which would be 60. You could also do in the absolute value 0 minus 60, which would be negative 60, but the absolute value makes it positive because our angles are positive. And there's your angle measure, 60 degrees. So again, a protractor is used to measure angles, angles 0 to 180 degrees. Now, if you ever take pre-calc, you'll see that there are many more angle measures than just 0 to 180, but for our conventional use in this class, that's what we'll stick with. And again, the reason you use the absolute value is because in our class, our angle measures will be positive. And again, that's not always the case. And you'll see that if you take pre-calc. Now, typically when we use a protractor, we try to line up one of the sides of the angle with 0, but you don't have to. And I think you'll see that in the next example. But again, what we did is we found angle ABC by looking at these two sides and finding the measure here. Cool. All right, so example 4, use the protractor postulate to measure an angle. It says, what is the measure of angle BEC? So I don't know if we've talked about this, but that little M stands for measure. So I'll just make sure I emphasize that. So that M is the word measure, and there's the angle symbol. So angle BEC is right here. So here's the B to E, and here's the E to C. So as I said, this is one of those examples where it did not line up the protractor with 0, which again I think is a little goofy, but and we'll make a note of that. So it looks like E to B, so side EB, I'm going to guess that it's somewhere between 45 and 50. So I think 47. And then E to C is right there at 105. So to find the measure of angle BEC, notice E is the vertex, so that's why it goes in the middle. To find the measure of angle BEC, I'm going to take the absolute value of 105 minus 47, or I could take the absolute value of 47 minus 105. Either way you slice it, the measure of angle BEC is going to come out to be a positive 58 degrees. Now again, usually we let one side be 0. Let one side be 0 degrees. Okay, so for instance, if I was going to, put that in, let one side be 0, not by 0, sorry, B0, BE, B0. So if I was going to look at angle AEB, for instance, AEB, this would be the situation I would use because A corresponds with 0. This side is 0, and you would just be counting up to 47. But again, the measure of angle AEB, would be equal to the absolute value of 47 minus 0, which is just 47 degrees. Okay, so that's how you use a protractor, right? Hopefully that refreshes your memory on protractors. Okay, next one. So now we're going to look at the angle addition postulate. So very similar to the segment addition postulate. So it says if D is in the interior of an angle, so that just means D is somewhere inside the big angle ABC. Then we can say the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. So again, ABD is from here to here. Let's call that X. DBC is from here to here. Let's call that Y. And then the big large angle, we'll call that Z. So again, in this situation, X plus Y equals Z. The two smaller angles equal the bigger angle. That's exactly what this long angle addition postulate is saying. So in this picture, it might be hard to see, but they're saying that this, first of all, they messed up. They didn't put D up here, so I apologize. This should if it matches their picture, this should really be D, this should be A, this should be C. But sorry about that. But anyway, so this top angle is 30, this bottom angle is 30. 30 plus 30 equals, and then the big angle is 60 degrees, and that equals. Now let me see if it'll take me to where I want to go, so I can play around with this. The angle addition is a little bit harder to see compared to the segment addition. Yeah, so I can drag A, C, and D around. So let's try to make some nice numbers. So there's a 70 and there's a 30, and 70 and 30 is 100, right? And again, I can make this one bigger, so I can do 70 and 50. 70 and 50 is 120. Simple angle addition. Okay, again, a postulate. Should just make sense because I said so, kind of stuff. Okay, so let's look at an example next. All right, so this one says a lighting designer is finalizing the lighting plan for an upcoming production. The spotlight can rotate 25 degrees to the left or right from the center. The beam of light from the spotlight forms a 22-degree angle. Can the designer use the spotlight to light each of the objects on the stage? So this confused me at first. So the first thing I want you to understand is that where the light is right now, this is considered center. So this is center. Again, I think it should be around the middle, but that's fine. So what we want to do is we want to know, are all of these objects going to be covered right now? Well, it looks like to me the door is already in the light. So I think the door is taken care of, right? And I said the door is taken care of because it's at the center. So take care. I think the rug is also, right? Because it's at the center. So I think the real question is the table and the chair, right? Is the table and the chair going to be covered by the light? Well, let us label the angle that the chair is x degrees. So this angle right here is x degrees, okay? And it's going to the left. So the chair is x degrees left. So what am I able to do? Well, I want to see if I can find out what x is. Well, it looks like, it looks like, well, this angle is 22 degrees, right? The angle of the light. And this right here is 57 degrees. So if this is 22 and this is 57, it looks like x would snuggle in just right here. It would be the difference of those two. So I think to find x, we're going to take 57 minus 22. That gives me an answer of 35 degrees. Which means that this light would have to rotate 35 degrees from its current position to get to the chair. Well, it can only rotate 25 degrees. So because 35 is greater than 25 degrees, this chair is not going to be able to be in the spotlight. Okay. All right, so now let's look at the table. So let's say that this angle right here is going to be y degrees. So the table is y degrees to the right. So let's try to figure out what y is. So it looks like we can use the big 74 and this 57 to subtract, because 74 is the grand total for all these angles, all three angles. 57 are these two angles, so what's left over for the y? So y is going to be 74 minus 57, and that comes out to be 17 degrees. And 17 degrees is less than 25 degrees. So yes, this time the table can be in the spotlight. So everything but the chair can be in the spotlight. Okay, so a pretty cool application of angle addition postulate, mostly angle subtraction, right? But same difference. Okay, so this is a very important slide on congruence. Okay, congruence is a huge topic in our class, and we're going to talk about congruent segments and congruent angles. So again, this is big time stuff. Make sure you pay attention. So let's start with the segments first. If two segments have the same length, then that means they're congruent. So for instance, I could tell you this segment is 5 centimeters and this segment is 5 centimeters. They're the same length, they're congruent. We also can use what are called dashes or tick marks, right? So in the picture above here, segment AB and segment CD have the same dashes, tick marks. They have one tick mark. So that means they are congruent, the segments, which means that their lengths AB and CD are equal. Now I put that bar across the top. I just shouldn't have. So let's see if I can fix that real fast with the eraser. Yeah, sorry, I was focusing on the top. So again, the lengths are equal. All right, same thing down here. Segment PQ and segment RS have two tick marks. They're congruent, or their lengths are equal. Okay, so keep that in mind as we go through. So again, when you name the segments without the dashes, that means lengths. So no dash means length RS. Okay, so a little nuancy thing that try to keep straight. Angles that have the same measure are called congruent angles. Notice we use what are called arc marks to show congruent angles. So in this case, angle TUV and angle XYZ have one arc mark. So they are congruent. So their measure, so the measure of angle TUV would be equal to the measure of angle XYZ. And again, I think I've said this once, but that little m stands for the word measure. Same thing down here. Angle FGH and angle JKL have two arc marks, so they're congruent. So since they're congruent, the measure of angle FGH would be equal to the measure of angle JKL. Last but not least, there are some properties that we should talk about. So first and foremost, we're going to talk about what's called the reflexive property. So the reflexive property says something is congruent to itself. So segment AB is congruent to segment AB, angle A is congruent to angle A. It's like looking at a mirror, right? It's like that congruence symbol is a mirror. Okay. The symmetric property I don't care about. The transitive property I also care about. The transitive property is a bit longer. So we're going to do it down here for the angles because it's easier to say out loud. So if angle A is congruent to angle B, they're the same measure, and angle B is congruent to angle C, they're the same measure, then this forces angle A to be congruent to angle C. I like to think of this as the transitioning rule, or we cutting out the middleman. So let's do some algebra. So let's say X is equal to Y, and let's say Y is equal to Z. Well, Y is the middleman. If say Y is equal to 3. Well, if Y is 3, then X has to be 3 and Z has to be 3. So we can cut out the middleman and we can connect the X to the Z. In the conclusion, X equals Z. So remember this transitive property as we go through, especially at the end of this chapter. All right, we got one more problem to do, and then lesson 1.1 is all done. Okay, so it says use congruent angles and congruent segments. Let's find some angle measures. If the measure of angle XWZ is 127 degrees, what is the measure of angle YWV? So in this picture, XWZ is the big angle. So that big angle is 127 degrees. We want to find YWV. We want to find this angle right here. Well, it looks like there are three angles that add to get the 127. This is 32. This is what we want to find. And then this right here is congruent to 32. So this one is also going to be 32 degrees. So let's call our question mark X and let's create an equation. 32 degrees plus X degrees plus 32 degrees needs to equal the entire angle measure of 127. Let's combine the 32s. X plus 64 equals 127. Let's subtract the 64. And X is 63. So the measure of angle YWV is 63 degrees. Couldn't have done that unless you recognize the congruent angles. B, what is the length of segment HF, right? Length of HF. Well, again, if I take a look here, where's HF? Well, HF is right here. HF is made up of two segments. So HF equals HG plus GF. If we can find the length of those segments, then we can find HF. Well, it looks like HG has two dashes on it. This segment AH has two dashes. They're congruent. So if AH is 11, guess what? HG is also 11. What about GF? Well, GF has one dash. Well, so does EF, but we don't know what EF is. So does BC, and BC is 8. So that means these two segments are both 8, which means GF is 8. Add 11 plus 8, and you get 19. The length of HF is 19, and there are units, centimeters, 19 centimeters. Great, you did it. You completed your first lesson in 2 videos. Thanks for watching. We'll see you next time.